the periodic table tutorial. If you look at some of my other little mini lessons, I've talked about the periodic table, showed you a couple examples, kind of went over the elements and all that fun stuff that you see on the periodic table, and I kind of broke it down some. So this is just an overview of the periodic table more. As always with tutorials, I don't answer the questions unless I feel that it is beneficial for you, and I let you watch the videos on your own. So we'll dive into this and just briefly talk about the periodic table. Okay, let's see what we have next. So it'll just talk about probably the different sections, different models, why it's developed, and all that fun stuff. So let's look at this. Yes, here's my favorite website for the periodic table again. Like I've said before, if you don't have this bookmarked, I recommend that you do. So here's the link right at the top too, if you need to type it in. But this is the periodic table. It gets more into detail about each element. You can click on it and you can review the element. There's uses, history, all that fun stuff. Okay, let's go to the next part, the video. I'll have you watch the video on your own. So excited this. Okay, so the development of the periodic table. So, and just a quick reminder, the periodic table is a chart which all known elements are organized by their atomic numbers and chemical properties. Okay, so people use the elements like to form copper, iron, gold, all that fun stuff. Basically, a periodic table is just an organization of all the elements, so you have it kind of in like one spot type thing. So 1800s is kind of when things started to get classified a little bit more. Okay, here's a scientist. He's discovering, self-taught scientist, we should say. And let's see, he arranged atoms. He arranged atoms by their weight. All that fun stuff. Okay, so here's how he was classifying atoms and how he was arranging them by their atomic weight. So this is the beginning process of organizing the periodic table. Then here's another scientist that it's how he's organizing the periodic table. So the process is already getting started. This Russian scientist was unaware and started developing his own periodic table. So it's interesting. We have many scientists over the years working on developing the periodic table, and they're all kind of doing the same thing, even though they might not be aware of what each other is doing. Okay, so here's a video. We'll watch that on your own. Groups. So elements are located, they're in groups and they're in periods, like different sections. So a group is a vertical column of the periodic table, typically consisting of elements with similar properties. So they're grouped together by similar properties. All right, so we'll go to the next part. And this shows Mendel's periodic table. So this is the periodic table the Russian scientist was doing, organizing the elements by similar chemical properties. It's just showing how they're organized together here. Okay. And here we go. We have, let's see, another scientist arranging the periodic table. He's arranging different elements based on their positions. And it has observed that. Okay. Here's our question. So I'll just scroll down to this part, and here's what each scientist has done. So we've Dmitri Mendel proposed a periodic table that accommodated for the discovery of new elements. Johann proposed a triad arrangements based on the elements' physical and chemical similarities. John Newlands, we have him, proposed a periodic table based on the repeating properties of the elements, like an octave in music. And then Henry Moseley proposed a periodic table based on the increasing order of elements in the elements' atomic numbers. So they all kind of have a similar idea of what's going on. Okay. Modern periodic table. Well, here's our modern periodic table. Here's all the elements and how they are classified. Okay, and here's our element. Here's the data with the element. We have the symbol, the number, the weight, and the name. So the 2 is the atomic number. Then the atomic weight is underneath the symbol. So He stands for helium. Then we have its official name right here. Okay, then it's talking about the periodic table. This goes more into detail about it as well, because you could click on each element and then let's click on helium because they showed helium for an example. And then it goes into more depth and it talks a lot about what's going on with helium and all of that. So groups and periods. Here are the groups. So as you can see, we have our groups here, and here's group 17 contains gases that are all reactive. So that just shows an example. Here's group 17, these are reactive gases. Each group has something in common, periods 1 through 7. So here's how they are assorted or arranged. All right, so here's a question. We'll let you answer the question on your own. So we have metals. Here's the different categories of metals in the periodic table. All elements on the left are metals, and then except for hydrogen. Hydrogen kind of stands alone, number 1. Metals also extend beyond the center and cover more than half of the table's right side. So they're solid at room temperature and good conductors of heat and electricity, and that is something pretty much they all have in common. But mercury, fun fact, is the only metal that is liquid at room temperature. Pretty interesting. So mercury was used in thermometers, for an example. And then let's see, they have a shiny exterior, malleable. Their shapes can be changed by exerting physical force. Pretty much common with all metals. Non-metals here, as you can see, they're in a different category. Top right corner of the periodic table, and hydrogen standing alone. So they can be a solid, liquid, or gas at room temperature. It really just depends on the non-metal, honestly. Poor conductors of heat and electricity, unlike metals, they aren't malleable or ductile. Common non-metal is oxygen because, well, obviously all animals must breathe to survive, so we all need oxygen. That's probably the most common, or the one that you're most familiar with. Metalloids, elements that produce properties of both metals and non-metals. They aren't ductile or malleable. They don't conduct electricity as well as metals do, but they're better conductors than non-metals. So they have properties of a little bit of both. Both things. We got both things going on with the metalloids. That's why they're kind of in a standalone category, just like this, and they're in between the metals and the non-metals. All right, we have our main groups, 1, 2, 13, 14, 15, 16, 17, 18. Transition right in the middle, which is 3 through 12. Inner transition, which is kind of on the outside, just kind of arranged a little bit differently. Let's see if we have, yep. This just shows if we place the whole thing together, it would look something like this. However, periodic table is differently. And the periods, okay, it says in the periodic table, these elements should have been placed in group 3, but they're placed at the bottom for convenience, so they're easier to kind of like tell things apart, and it makes it a little less long. Okay, let's go to alkaline metals and alkaline earth metals. So there's 2 different categories here. And you've probably heard of these before, the word alkaline. And these metals, alkali metals, these metals are soft and light. Although they're metals, they can easily be cut with a knife. That's a fun fact right there as well. Alkaline earth metals are light and reactive. So the ones right here, alkaline earth metals, are in the red. Halogens and noble gases. These are, the noble gases are on the outside. As you can see, we have helium right at the top. Halogens right here. And halogens are highly reactive, so it's difficult to obtain a pure form in nature. And these are also non-metals. And group 18 is the noble gases. These elements are noble gases. They're gas elements. Nothing too exciting about them. Let's see. They often use in like laser lights or neon lights because that's what kind of light that they would give off. These elements are similar elements to each other. They appear together in the periodic table because this was the way that the Russian scientist Mendeleev organized the elements. So that's how they've always appeared together like this and why they're still like this today, why they're grouped together. Okay, we'll let you do that part on your own. All right, we have the electron structure. So in the periodic table, it'll say the valence electrons, which is like electrons in its outer shell, and it states it on the element. So if you look, it'll tell you, let's go to oxygen, and it should say how many electrons are in its outer shell. So it kind of gives you an idea. Okay. And then it says that the elements in the modern periodic table are arranged according to their chemical properties. The chemical properties in turn depend on the distribution and position of the electrons in that element's atoms. The position of the electrons is the reason for the irregular block structure of the modern periodic table. So again, that's why it's the structure of the periodic table is kind of broken down some. So then we have the metals, metalloids, nonmetals, and unknown. This group right here, the last of the elements, they are unknown. We're not quite sure what they are. But elements are also arranged by the electrons in their outer shells. As you can see, here's an example of the electrons in their outer shells. So energy levels. A state of an electron in an atom represented by a positive integer that relates to both the electron's energy and to its most probable distance from the nucleus. Pretty interesting. So we have 1 ring, 2, then 3. So energy level 1, 2, and 3. This sodium atom has electrons in 3 levels. And the third energy level isn't full. It isn't full, meaning it could hold more, so it could have more bonds with each other. So the third energy level can hold 18 electrons, so meaning sodium can bond with other elements and it can share electrons with each other or with other elements. Valence electrons, all right. Quick review. However many protons are, they'll be the same number of electrons, positive, negative charge. Protons are positively charged. Neutrons are neutral. They have no charge. Electrons are negatively charged. Okay. Valence electrons. An electron in the outermost energy level of the atom. That's that last shell. So in this instance, there's only 1. Valence electrons will let you answer this question. Okay. So showing the number of energy levels as we go down. And as you can see, it looks like there is an increase. So hydrogen only has the 1. It would be 1 energy level. And if you look closely, you can see that the energy level of the valence electrons matches the period number in which the element is found. Very interesting. Fun fact about the periodic table. So for an example, it says sodium is in period 3. Okay. Meaning, here we go. The valence electron is in its 3rd energy level. So then 3rd energy level, number of energy levels, as you can see, it goes how it appears to be increasing as we go down. It only has 3 energy levels for sodium. The elements at the bottom have number of energy levels 7. Sublevels, all right. A state of an electron in an atom within a given principal energy level that relates to both the electron's energy and the shape of its orbital, meaning the shape of how it is moving about. So here's just some different examples of shapes here. Okay, here's just another number of orbitals. It goes down 1, 3, 5, 7. Number or just shows different shapes, other models divided into orbitals. Let's read the definition. A region of space around an atomic nucleus in which an electron is likely to be found. So here's just the region, the orbitals, and shows the different shapes. This is just giving us a couple more examples. It's showing the max number of electrons they can have in its outer shell. So if it has number of orbitals 1, max number of electrons 2. 3, the max number would be, it keeps increasing. And as you can see, it keeps increasing as you have the max number of electrons, the orbital shells get bigger and there's more. Okay, now we have our main groups, periodic table, and then we have inner transition elements, transition elements. Okay, so real quick, first energy level can have 2 electrons. Second energy level can have 8 electrons. Third energy level can have 18 electrons. In our electron diagram, I also did a mini lesson on this one that shows the electrons around the element. So this is just an example of what it would look like. We'll let you figure this one out. And the same thing for these. That's about all for this one. So hopefully that clears up the periodic table just a little bit more and gives you a little bit better of an understanding.